Okay, so we completed till over here, and then let us enter to our main domain. By using these plates, I want to enter into the topic which we call it as capacitors. Is that clear? Date is today 5th May. Now look over here. What is the meaning of capacitor? ठीक. अच्छा अभी let us take some examples and then we'll move ahead. ठीक है ना? Okay, so let's get first. अच्छा एक बात बताओ. Let's suppose consider जैसे मान लो मैंने इलेक्ट्रिक फैन लिया. ठीक. या फिर तुम कोई मोटर ले लो या फिर रिमोट स्विचेस मोबाइल फोन जैसे स्विच या फिर कोई भी रिमोट ले लो है ना. कैन यू आइडेंटिफाई अ कॉमन फेनोमेनन इन ऑल ऑफ देम? बताओ. कैन यू सी अ कॉमन फेनोमेनन? हाँ हाँ. What is the biggest thing in all these three? Achha, did you have seen that they instantly respond to the switches? Did you have seen that they instantly respond to the switches? Like as you switch on the fan starts to rotate or not? Or does it take some time to generate that energy and then it starts to rotate? Basically, rotating fans is very very hard, isn't it? Similar. Yeah, same for motor and in remote also. Whenever you press a switch, at the same time the TV responds to it or not. So these three have one common phenomena that to start instantly they require enough energy, isn't it? To respond instantaneously. This is not see. This is like they want the energy at the same instant of time. So there should be some device which can provide some instantaneous energy or not, and that device is called as capacitor. Yeah, so capacitor is that device. Look over here. Let us define and then we'll move ahead. Okay, so look over here. Uh, Let us first define a capacitor. It's that device which stores energy okay and releases instantaneously. We can take an example of our different cases. Are you able to get me? Is that clear? So we have to always use capacitors. There are many electrical appliances which uses 1 minute. Mm, okay, so look over here. Basically, the point is that our capacitors generally are those kind of electrical devices which have a very great application in modern day life. Like anything which you are making, like refrigerator or a TV appliance, anything which requires instantaneous energy is going to be operated by a capacitor. Are you able to get me or not? So basically, in this chapter, what we want to understand is that how this energy is stored. Are you able to get me? So this chapter deals with that only. Okay. Now, like let us understand in a much more depth sense that what is the real meaning of that. Now look over here. Let's suppose I consider a hollow sphere. ठीक है? अगर मैं एक hollow sphere मानता हूँ, है ना? अब ध्यान से देखो, this hollow sphere will have some radius r or not, isn't it? Now, if I consider some radius r, then let's suppose I charged this hollow sphere. ठीक है? So I charged it. And this is plus plus plus, isn't it? Now look over here. When you charge the hollow sphere, we know that the particular charging of object increases its energy or not. Yes. So let us write all the things. Then I will understand. So hollow sphere. Okay. So let's suppose a hollow sphere of radius r and charge q is there. Now, Balak, you can see that the electric field due to this hollow sphere will be present in these random directions. Agony. Sorry. Will present in these random directions or not? Now, what is the meaning of this electric field? If I say that, sir, I have some electric field, then what's the real meaning of that? You know that for the electric field, you have some potential energy. Yes. So see that what you can observe is clearly written over here that if I have any kind of a charged object, then that charged object stores the energy in terms of electric field, isn't it? Yes. And that energy will be available from, so look over here, in this sphere only, the energy, okay, will be available from R to infinity only, है कि नहीं? यहां से लेके इनफिनाइट तक ही तो एनर्जी अवेलेबल है ना? तो इसका मतलब क्या, अगर तुम खुद सोचो, अगर किसी चार्ज ऑफ एक बॉडी है, एक बॉडी को तुम यहाँ से मतलब इस स्फीयर के सामने you try to move another charge, you will see that you need to do some work till over here, isn't it? And then if you just made a small hole and if you are moving the charge inside it, there is no work done required. Why? Because inside it there is no electric field. Are you able to get me? Exactly. So that means what? That energy is available from where to where? From R to infinity. And a coincidence you can see that from R to infinity only my electric field is also there or not. So that means what? What is the meaning of that? That means that for any kind of a conductor, I can store some energy, and I can store some energy in form of what? In form of electric field only, isn't it? अरे कुछ तो बोलो हाँ है ना? Is that clear? Are you able to get me? So look over here. So you can see that the potential energy of this conductor is how much? KQ square by R. अगर मान लो बाहर से कोई चार्ज आ गया है ना, तो पहले बात क्या है कि हमें मतलब फर्स्ट कंडीशन इज that to store energy you require an external charge also. Apart from the internal charge, you require which charge? External charge, or also otherwise this potential energy will not be generated. Are you able to get me? So the first condition is that whenever there are two conductors placed at some distance apart, they starts to store some energy due to the presence of electric field between them. Are you able to get me or not? So did you got the idea why there are two plates or three plates to create the capacitor? Why does not a single plate will create the capacitor? Okay. Next thing that, so look over here, as we have the energy now. Now a different like जैसे मान लो you know that human like we eat something isn't it and then we perform the work है कि नहीं जैसे हमें हमें इंस्टेंटेनियस एनर्जी के लिए क्या चाहिए ग्लूकोज की शक्ति चाहिए है कि नहीं खाना चाहिए तो basically you will see that some people are eating more some people are eating less so they will have basically you can identify on the basis of how much they are eating and how much they are utilizing it as energy or not. So basically, there should be some property which should understand that yes, different conductors should store different kinds of a different level of energy, isn't it? And that property of the material which defines the storage capacity is called as capacitance of the body. Is that clear or not? Yes. So look over here. So definitely it is necessary to define for a conductor. So for a conductor, we define capacitance, which tells us that how much, which you can say that this is defined as capacity to hold the charge in conductor. Is that clear? Yes, because it is necessary now. Like you only think that if a conductor is small, then it will have some another property of storing the charge, isn't it? If a conductor is big, then I'll have more charge. That means more energy. Are you able to get me? So this is why it is necessary to understand that the capacitors will definitely hold some charges, and that's why we define capacitors. So capacitors, then we have the capacitance for them, which tells us that how much charge can be stored and how much energy can be instantaneously generated. Are you able to get me? So just like see, earlier you have studied this, like you can say that just like we have resistance for the case of our current or not. Similarly is my capacity. Is that clear? And the capacity, or you can say capacitance, then the capacitance of any material is defined as, this is what is happening to me. I don't know what has happened. What is this heat is creating a problem or what? And that is why we define capacitance of material as C is equal to Q by V. Are you able to get me? Is that clear? So look over here. Let's suppose, like right now we discussed for the sphere. You know that the potential of the sphere is given as what? KQ by R. And that look over here. See, point is simple. That you will store the charge till only the radius. Now, out of that, can you store? No. Inside it, you can't. Means if I have a radius R, then the charges will be present on the surface. So capacitance means if I am defining capacitance, I have to define the potential with respect to the surface. So this V is for the surface. Are you able to get me? So let's take an example of a spherical conductor. जैसे मान लो मैंने एक spherical conductor consider किया for a spherical conductor The potential on the surface is always equal to how much? 4 1 by 4 pi epsilon naught q by r or not? Yes. So if I put it over here, can you see that the capacitance will be given by formula? This implies C is equal to nothing but just 4 pi epsilon naught into R, isn't it? Yes. So this is the capacitance of spherical conductors. You can learn it directly, simple. So to understand, typically I just took an example. Why? Because I wanted to understand some of the things that see, तुम खुद ही सोचो एक बात बताओ मान लो एक गरीब है let's take an example मान लो there is a poor guy and he is hungry so he wants to fill his stomach are you able to get me now is he going to look that yes I'll go to the restaurant and I will eat Japanese Thai sushi and then only then my hunger will be done isn't it means this is not the case isn't it he will if he is hungry he is eager to eat anything isn't it मतलब उसको कुछ भी चलेगा भाई वो मतलब ऐसे दौड़ेगा नहीं कि मतलब कि मेरे को समोसे ही चाहिए है कि नहीं तो वैसे ही अपन का चार्ज और पोटेंशियल है ना पोटेंशियल क्या है पोटेंशियल सरफेस टू सरफेस वैरी करता है मतलब अलग अलग रेस्टोरेंट के अलग अलग डिफरेंट डिफरेंट पोटेंशियल्स इजंट इट अलग अलग आइटम्स एंड डिफरेंट डिफरेंट क्यू मीन्स व्हाट क्यू मीन्स टोटल नंबर ऑफ आइटम्स और नॉट so the capacity should be independent of all these things isn't it means my eating capability is independent of number of items and types of items isn't it and this is what is very important thing to understand that capacitance although the formula of capacitance is given as q by v but it is independent of first thing charge on the body and second thing potential of the body is that clear capacitance is truly totally independent of these things but then the question arises that on which thing it will depend अब तुम खुद सोचो जो ज्यादा मोटा है जो तोंदुमल है वो ज्यादा खाना खाएगा है कि नहीं तो सिंपल बस capacitance is dependent on first size shape and size of the body of the conductor या body लिख लो है ना second point is very important नेक्स्ट थिंग अब मतलब जैसे मान अब घर में खा रहे हैं तो जैसे इफ यू गो टू द रिलेटिव हाउस एंड लेट सपोज आई ईट इन माय होम 8 rotis but when I will go to my relative house I'll eat only 2 rotis or not because to show off yes I eat less isn't it so that's how is capacitance also it depends on our surrounding medium is that clear and third thing presence of other conductors are you able to get me is that clear perfectly so now so this is the property of our capacitance of the bodies that how the capacitance is represented now look over here next point basically we should define the units of capacitance isn't it here only I'll define so units of capacitance is farad and sometimes we call it as microfarads sometimes it is given in nanofarads picofarad also are you able to get me but the main thing is the dimension of capacitance Okay, tell me what will be that? बताओ सोच के बताओ. C is equal to Q by V फॉर्मूला होता है ना. Hmm. हाँ. I'm asking dimensional formula. That means you have to write in terms of MLT, ampere and all. Think what will be that? Should I tell? See, the most easiest way is Q multiply, make it Q square and multiply Q with V. QV is what? Work done, isn't it? So I can write Q as what? Q as I into T square divided by Q into V is work done, which is ML square to the power of minus 2. Are you able to get me? So therefore, yeah, it was given as simple. M to the power of minus 1, L to the power of minus 2, to the power of 4, and I, which is amperes, ampere I square or ampere square, whichever you want. Is that clear? This is my dimension of capacitance. Are you able to get me? Is that clear? So, ma'am, so this is how you are going to find the dimension. All there are many things. Okay. Now, look over here. Let's suppose if I have a question arises that if I see a capacitor, okay, of any arbitrary shape. Now we will talk about something. Now its capacitance means if we charge this object. So look over here. What I'm doing, I'm charging this arbitrary shaped body. Taken. Then due to this, some potential will develop on the body or not. So for a neutral conductor, I need to provide some charge, and that charge will give me C is equal to Q by V. Are you able to get me or not? Question arises that when you provide this charge and when this potential gets developed, I know that some energy will be stored in this capacitor or not. And due to this, the energy gets stored in form of electric field. The question arises that what is that energy, isn't it? Are you able to get me? So let us see for an arbitrary shaped conductor, energy, how much energy is stored. So I'll consider this conductor as capacitor. So give the heading energy stored in electrical energy basically in capacitor. Are you able to get me? ठीक है? Okay, so look over here. Let's suppose if I have an arbitrary shaped conductor, okay, is that clear? Which has originally charged Q and potential how much then V. Are you able to get me? Are you able to get me? So basically, what let us just charge it 1 minute. So look over here. What I'm doing is I am bringing some charge from the infinity. So let charge a capacitor by bringing charge from infinity. Is that clear? So let's suppose if I'm bringing some charge from infinity and that will develop some charge. Got it? So a minute, let me draw a big line. So there is this point infinity and I'm bringing some charge dq from there. Are you able to get me? Now, so look over here. Basically, to to bring this charge, I need to do some work or not? Yes. And this body has originally some charge q and some charge how much v over there. Is that clear? Potential how much v. Are you able to get me? So to bring this charge dq inside the body, you need to do some work. But that work can be stored as the energy itself. That see, if I am doing work, you know that the electrostatic force is a conservative force. So that work is equal to negative of change in potential energy. Yes. So that means what? That originally some energy. That means that that potential energy is can be stored as the energy in terms of the body or not. So that's what I'm writing. So work done by the external agency is stored in electric field energy. Are you able to get me or not? So there is a reason for this because you should always remember that work done against any kind of a conservative force is always stored as energy. Is always conservative force है field लिख लो बालक mainly field लोग लिखते हैं ना is always stored as energy in conservative field. This is the natural phenomenon है ना. जैसे इसका एक बेस्ट एग्जांपल होता है मतलब लेट सपोज व्हाट वी डू व्हेन मतलब if I consider a hill. So look over here. When this ball is kept on top of hill, when it comes down, it has some velocity or not. That velocity will only appear when there is some initial energy, isn't it? That will convert into velocity. So how that energy would have came over here? That energy would have came because when you are lifting this body against the gravity, and gravity is a conservative force. So you are lifting this body against the gravity or not. That means you are doing work against the gravity. So that much work, when you keep it this body at rest, this body will store that work as energy. Is that clear or not? And that can be utilized later time. Okay. So look over here. So if I bring this charge from infinity, so amount of work done will be how much? It will be dq will be equal to dw will be dq. Final potential is V. Initial potential is how much? 0. So dq into V minus 0. Are you able to get me? So dw is equal to dq into V. Are you able to get me? But as you know, dq V is how much? Q by C. Because Q is equal to how much? CV. Isn't it? So I can write V as Q by C. Can I integrate this? So net work done is how much? 1 by C is constant, so it will be half Q square or not? Q square C or not? Alright, sorry, Q square by C. Half Q square by C. Are you able to get me? But this work done is only stored as what? Energy. So therefore, energy is stored in the capacitor always due to the charge Q during charging. Okay, is given as half Q square by C. Are you able to get me? I can even put Q is equal to CV and all. So what I will? So it will become half CV square, which is commonly used, isn't it? Or it can be written as also. There is a one more formula which is written as QB by 2. Are you able to get me? So this is the energy stored in the capacitor. So we did energy stored, we did capacitance. Why capacitance? And then we have done the field and all, isn't it? Now tomorrow, let me stop.